This meeting is being recorded.
Okay, Cassidy,
Here.
Alejandro, Liliana, Lainey,
Here.
Cassandra,
Here.
Romeo Diaz, Brenda,
Here.
Jasmine,
Here.
Josue,
Here.
Jade,
Here.
okay, Valerie, Edsel,
Here. Here.
Valerie's here, Joel,
Here.
okay, Monique, Salvador,
Here.
Caitlin,
Here.
Kayla,
Here.
Romeo Ramos,
Here.
Paula Robles,
Here.
Ricardo Vasquez.
Here.
Okay, anybody did not call? Okay, sounds good. Okay, so we have an exam on Wednesday, So I'd like to go over some of the questions on the review. I've already been asked to do a few of them. If there are specific ones that you would like me to go over, please let me know. You can let me know via the chat. If there are ones that you think are going to be troublesome, so please let me know. Okay. Oh, sure. Okay, so the first request I have is, it says, can you go over 9.1 question 2? Okay. So yeah, let me go over that first. 9.1 question 2. Let me see how what that is. Okay, is this the one? Okay, so this says, what is the total frequency of deaths? Okay, what is the total frequency of deaths from 2006 through 2009? Okay, so the total frequency of deaths from 2006 through, so the following frequency table contains the total number of deaths worldwide as a result of earthquakes from 2000 to 2012, okay? What is the total frequency of deaths from 2006 through 2009? Okay, let's see what we got here. So 2006, we have 6605. 2007, we have 712. 2008, we have 88,011. 2009, we have 1790. 1790. And so I'm assuming we just add these up. Let's see what we get. Maybe I'm wrong for thinking so. 6605 plus 712 plus 88, because this is through 2009. So I would assume that 2009 would be included. Oh, this is, I don't know what I'm doing here. This is 88011 plus 1790. 1790. Okay, I'm getting 97,118. It's probably not the right answer, because if it was, nobody would be having a problem with it, probably. Okay, so let's see what we got here. 97,118. Okay, submit question. They tell me that's right. So I just added up the ones they gave me from 2006 through 2009, and that was the right answer. I don't.
Wait, so the years that you added up, I just want to make sure it was the years 2006, 2009?
Yeah, all of them, yeah.
Okay, okay, I see where you, I just saw that. I was about to ask you where's the direction, but I just saw it. Okay.
It was 2006 to 2009 inclusive. Included everything. So, yeah, that's fine. I mean, if sometimes they're glitchy. I mean, honestly. So, I mean, if you want, yeah. So let me see here. So if you want me to, I might be able to get rid of that question. So let's see. No, we don't want to do that. What do I want to do here? Back in here. If I want to get rid of a question, how would I do that? Nope. That's not what I want. Just sending me to the other one. It's question 2, right? Set all student scores to points possible. Withdraw question. There we go. There. Boom. Everybody gets that one correct. There you go. Okay. So now I would need to click done here, and then I'm going to go back to Canvas, and I'm going to update everybody's grade. So let's go down to, yeah, it should update within the next 24 hours automatically. Okay, sounds good. Okay, so that was on the homework. What else? Lainey wants me to go over interquartile range. Okay, so let's do an example of that real quick. Let's see if one of the practice problems has a. So if I don't get to one that in the practice problems, then I'll just make up one on my own. But let's go into the practice problems. Assignments. Okay, let's start working through a few of these. So exam 3 review. Okay. Actually, let me go here real quick. If you get something wrong on the review, does it tell you what the right answer is?
No.
No, okay. Let me change that. So display style, new versions, okay, blah, blah, blah. Show scores on each question immediately, okay. Show answers, never, no. After last try on the question, there we go. Show the answers. Okay, students can view their work immediately. Students can view their scores immediately. Students can view correct answers in the grade book. We're not using the grade book. I'll put after the due date. No, that's not going to help you because after the due date is well, whatever. Gradebook categories, homework, number of versions, blah, 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 number of tries on each version, number 1. Okay, without a penalty, blah, blah, blah. Okay. Let me save that. Save changes. Okay. Log into Canvas. Let's go back to the Canvas. And we'll go into 105. And we're going to do the assignments. And okay, we will do. Oh, not that. What's the exam 3? Review. Okay. Okay, so let's see what happens here when I start this bad boy. Okay. So I had some questions to go through. Okay. So 3 and 4. Let's see what 3 and 4 are. It says, we want to know the percentage of California that will be voting for Mr. Lewis in the next election. We call 50 random numbers in California and ask, are you planning on voting for Mr. Lewis in the next election? Match the following descriptions with the appropriate key term. Okay, the responses of the 50 random numbers called, okay, is, oh, okay, we want a population, statistic, sample, or parameter. Okay, the response of 50 randomly selects call, that's, the responses are going to be the sample. So I'm going to go with C on that one. Okay. The responses of all voters in California, I'm going to go with the parameter on that one. D. Okay, it's just kind of like a census, right? So, okay, and the proportion of all voters. Okay, proportion of all voters, that's a statistic. Or no, that's a that is, wait a second. C is a sample, sorry. This is a sample. The first one should be, yeah, that's correct. It's a sample, okay. Parameter, oh, it's a parameter. So A is the population, sorry. This is A. So the response of all voters in California is the population. Okay, that's the population. Okay, the proportion of all voters in California, that's the parameter. Proportion parameter, that's D. Okay, and the proportion of 50 random numbers, that's the statistic. Statistic always comes from a sample. That's the statistic. B. Let's see. There we go. Okay, worked. Okay, number 4. We had number 4. Political scientist surveys 26 of the 150. What's the sample size? Okay, well, I only surveyed 26 of them. So that's a 26. And what's the population? What's the size of the population? It's 150, right? Oh, okay. Okay, to determine what the key terms refer to in the following survey. Oh, that was number 5. Let's skip to number 8. Skip to number 8 here. Okay. In the study, the data you collect is age in years. Is that quantitative or categorical? Well, age, age in years. That one's interesting because could you add and subtract and multiply and divide ages? Sure you can. So I'm going to go with, okay, categorical on that one. I mean quantitative. I'm going to go quantitative. And that is correct. Okay. 20. I had a request for number 20. Okay, number 20 here. Okay, based on the histogram above, what is the class width? What is the class width? Okay, so that's the bin length, right? So it looks like if I subtract 7 minus 1, I'm going to get 6. This looks like to get from to the next bin, I'm always going up 6. So I'm going to put 6 for my bin width here. 6. Okay, what is the sample size? Ooh, what is the sample size? That one's interesting because what you have to do is you have to add up the total frequencies here. Okay, if there are 9 in the first column, then what you have to do is you have to add up 9 plus 2. Okay, 9 plus 2 plus 4 in the next column plus 3 in the next column plus 8 in the next column plus 7 in the last column. If I add up all those numbers, what am I going to get? I'm going to get, looks like 33 maybe. I'm thinking, yeah, let's add up all those numbers and let's try 33 here. Boom, look at that. That's good. I'll keep my job today.
Professor, how do you get the class width?
See that 7 and see the 1? 7 minus 1 is 6. 13 minus 7 is 6. 19 minus 13 is 6. It's all 6.
All right, thank you.
Okay. And 22. Okay. Based on the histogram above, what is the bin? Oh, same. This is the same thing. I gave you the same question twice. Okay, so what's this one? What's the bin width here? Yep, 5. Exactly. This is the 5. Thank you. Edsel, good job. Sample size. What's the sample size going to be? Let's see. Well, I've got a 10 plus a 6, that's 16. Plus 8 is 24. Plus 9 is 33. Plus 3 is 36. Plus 2 is 38. Let me try that. Yep, the computer likes that one. Okay. Okay, and then what else we got here? We got number 40, and then I think 43, 45, 46. So into the 40s we go. Okay, 40. Aha, oh yeah, 40. That's nice. Okay, what's the 5-number summary here? Okay, so I've got 5, 6, 13, 29, 32. Okay, so if I list these out in order, I don't think I can write on this, can I? Nope, can't. But if I list these numbers out in order, what can I do here? Let's bring this up. Let's make it a little smaller. So I just kind of have like a little notepad here. Okay. And so that looks good to me. Okay, and so what do we have? We have 5, 6, 13, 29, 32, 36, 55, 78, 85, 93, 94, and 96. Okay, so how many numbers are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So I break this in half. I get 6 and 6. So 6 and 6. Okay. 6 and 6. Okay. So what is going to be my minimum number? My minimum number is 5. What's going to be my maximum number? Maximum number is 96. Okay, so that's, now I need to know, well, what's my middle number? What's Q2, or my median? Median, also known as Q2. Well, that's going to be the average of the middle two, because it's even. So this is 36 plus 55 over 2. Okay, so grab a calculator. 36 plus 55 equals 91 divided by 2 is 45.5. Okay, now what about Q1? Well, that's going to be the lower, that's going to be the median of the lower half. Well, that's going to be the average of these two. So this is Q2, this is Q1. Okay, and then what's this guy going to be? This is going to be this guy here. Those two, the average of that, that's Q3. Okay, and so Q1 is going to be 13 plus 29 over 2. Okay. And Q3 is going to be 85 plus 93 over 2. Okay, so 13 plus 29 divided by 2 is 21. Okay. And then 85 plus 93. 85 plus 93 is 178 divided by 2. That's 89. So here's my 5-number summary. 5, 21, 45.5, 89, and 96 is my 5-number summary. Okay, so that's my 5-number summary. So let's plug that in here. Okay, so we have 5. Okay, so 5. Then we had 21, I believe. Sorry, 21. Okay, so 21. Okay, and then the median would have been at what, 45.5, I think. Let's see. Let's go back. Yep, 45.5. 45.5, and then we have okay, 89 and 96. 89 and 96. So 89 and 96. Okay, and then the IQR. Okay, the IQR is the interquartile range. That's the Q3 minus Q1. So in this case, it's 89 minus 21. That's what the interquartile range is. So the interquartile range is Q3 minus Q1. Okay, so Q3 minus Q1. That's the IQR. It's the range within the box. I'll show you in this what I mean by that here. So if I go to the box, okay, if I were to do a box and whisker plot here, we have 5, and then we have a bar at 21, and then 45.5, and then 89, and then 96. Okay, the IQR, the interquartile range, is the distance of the box. Okay, it's the distance of the rectangle. This is the IQR. Yeah. Okay. And so the IQR here is going to be 89 minus 21. That's the interquartile range. Okay, is okay. Is 89 minus 21. So what is that? 89 minus 21 is 68. Okay, so that's the interquartile range. 68. Okay. And then the 1.5 times IQR rule states the values between blank and blank are likely not outliers. Okay, so how do we find these 1.5 times the IQR? Well, if I do 1.5 times 68, okay, that's the IQR. 1.5 times 68. Well, not that. 1.5. It's like 102, I think. 1.5 times, oh my gosh, clear off for me. 0.5 times 68 is equal to 102, yeah. So 102, right? So it's saying, what are the outliers? Well, outliers, okay, are 1.5 IQR above Q3 and 1.5 IQR below, okay, below Q1. Okay, so they're above Q3, below Q1. I don't know if we covered this, probably didn't cover this in class, but 1.5 IQ are above Q3 and 1.5 IQ are below Q1. Okay, and so if I take this 102 and I add it, okay, I add it to 89. So take Q3 and add 102. Okay, that 89 plus 102, I get what? 191. Okay, so that would be my, anything less than 191 would not be considered an outlier. Anything above 191 would be an outlier. Outlier is kind of just these wacko values that are way too high or way too low. Okay, Q3. Q1, this is going to be even weirder because my lower value is going to be Q1 minus 102. Okay, and so this is my lower boundary. And so that's going to be 21 minus 102. 21 minus 102 is negative 81. So that's negative. Anything lower than negative 81 would be considered an outlier as well. So let's go back here. We had negative 81. Oops. Okay, negative 81. And 192, I believe. So 192 or 191? Let me see. 191. Okay, so it was 191. Okay, submit. Boom. Yeah. Yeah, that one's a hard one. We didn't cover that in class. It is in the book, but we're really not following the textbook per se. So yeah, I could see why that one gave people challenge. I'll make sure that something like that's not necessarily on the exam, although now you know how to do it. So, but regardless, so this is number 40, right? Okay. Okay. 43. Lainey says, please do 43. Okay, let's see what 43 is. Is it the same thing? Okay, researchers are interested in looking into the air quality in different regions of the United States. The following dot plot represents the number of days in a certain month. And the dot plot is basically just a histogram with dots. Okay, there's a frequency. The number of dots is the frequency, and the bins here are 1. Okay, the bin widths are 1. Okay, which of the following is the dot plot is the box plot of this data? Okay, so we have 2 zeros. Okay, we have 1, 2, 3, 4, 5 ones. Okay, so yeah, we could kind of just list out the data, and then you know, we could calculate these values. Okay, so maybe we'll do that here. Okay, let me scroll this up so I have more room. So what's the data here? Well, I've got a 0 and a 0. I've got a 1, 2, 3, 4, 5 ones. 1, 1, 1, 1, 1. I've got 2 2s for all you ballerinas. I've got 1 3. And I've got 2 5s. I've got 1 6, 2 7s, 2 9s, and a 12, right? Okay, so how many pieces of data do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces of data. Okay, so let's look at the 18 pieces of data. Let's go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll split that in half. Okay, what's the median here? Well, the median is going to be halfway between 2 and 2.3, which is 2.5, right? 2.5 is the median. Okay, we got 9 above and 9 below, so we actually do have a Q1 because it's odd. We have 1, 2, 3, 4, 5. The fifth number here is Q1. It's right in the middle, Q1. The 1, 2, 3, 4, fifth number here is 7. That's Q3. Oops. Q3, okay, and this is the median, which is Q2. Okay, and then we've got the min, which is 0. And we've got the max, which is 12. Okay, cool. So what's, whoops. Heck, man. Stop. I'm trying to move everything. Go back. Okay, let's move this up. Okay, so what's the box plot going to look like? Well, we're going to be from 0 to 12, right? 0 to 12. Cut that in half. Okay, I get 6 and 7. Okay, and then 1. 1 is going to be, say, this is 6. So 5, 4, 3, 2, 1. Okay, looks good. And then 0, 0, 1, 2, 3, 4, 5, 6. And then this is 7, 8, 9, 10, 11, 12. Okay, that's good enough. Okay, so we just want to know what's the shape of this thing. Well, there's going to be a dot here, and then it's going to be a bar at 1. And then at 2.5, we're going to have the median. Okay, at 2.5. And then at 7, we're going to have Q3. 7. So we've got this thing here. Okay, and then we've got a max at 12. Okay. So I want something that looks like that. Okay. It's pushed more to the left here. Okay, so let's see which one looks like that. B. Oh, look at that, B. Nope, not B. Because look where the median is for B. B is that the median is at 4. Oh, D. Look at that. D has D. I think D is a winner here. D. Yeah, 0, and then 1, and then 7, and then 2.5. I think D is it. So let's go D, submit question. Yep, that's the answer. Okay, let's see what we got here.
Will one like this be on the test?
Yes. Possibly. Okay, and then what else do we got here? 45 and 46. 45 and 46. Below are two different classes score on a 6-point pop quiz. The mean for each graph is given just above. Okay, so the means are given. It says class A has the larger standard deviation. Okay, class B has the larger standard deviation. Both have the same standard deviation. Okay, the mean is 3 in this one, so, and cannot be calculated from the information given. I don't know, I'm going to try first cannot be calculated from the given information, simply because one, we don't know what the measurements are. We just know that we have measurements that fall somewhere between 2 and 3. And then we could calculate these if we knew that this is a 6 point. So if there were no partial points, then then we could calculate the standard deviations here. But we don't know if there are partial points given. We don't know if you can get a 5.5. I mean, I guess not. I guess there are no partial points, because then that would be part of the frequency. So, I mean, we could calculate. I guess we could calculate this, because where they're saying that the score, no, we don't know. Because this is the score, right? The score could have, say that I have a score of 2.5, that would just go in the between 2 and 3 column. Yeah, so we don't know if it was graded with partial points or not. We can't calculate the standard deviation. Now, could we even see if one was bigger than the other? Remember, what makes the standard deviation big? Well, it's if the values are all spread out. What makes the standard deviation small? Well, if the values are all bunched together. The problem is that here we have a standard deviation at 3.3, which means that there's a bunch that are above 3.3, but there's also a bunch that are below. It's the same thing over here with 2.57. We have a bunch that are above 2.57, but there are a bunch of below. So I'm gonna say it's really too hard to tell for this one. Nope, I got that wrong. Okay, so why am I wrong? Let's see. So if I got it wrong, then this would be one that I'm gonna get rid of as well. You're not gonna have one like this. This is too hard on the exam. So what is the correct answer? Let's get a similar question here. Okay, so what is the correct answer? So if we assume that there are no partial points, if we make that assumption that there are no partial points given, you either you get it either right or you get it wrong, then we could calculate the standard deviations. So you're going to have to make that assumption though. Okay, I don't like making assumptions, but they're not leaving me any other alternative because they're telling me that I'm wrong. If I make it more general, so let's go over this one. Okay, so how many people got 0 on the exam for group A? So how many zeros were there? We're going to say that there are 2 zeros. Okay, how many ones? We're going to say that there were three ones. How many 2s? This doesn't make sense. Again, it doesn't make sense because if I do a right hand or I do a left hand limit between 2 and 3, if I just include 2, I can never get 6, and 6 is a perfect score. Okay, so I'm gonna say that B has the largest standard deviation. Let's see what that is. Yeah. Okay, so you can't calculate it. The reason that B has the larger standard deviation here, the reasoning behind this. Let's go through the reasoning. Okay, you can't. The reason that I chose B was because of the shape. Okay, so think of it this way: we have this shape, right? And we have this shape. Okay, and so we have kind of like this mound shape. Okay, so there's a lot less values that are further from the center. Okay, a lot less values further from the center. There's more values in the center. Okay, so that's going to give me a smaller standard deviation. If I take the center here, and this doesn't have a lot of values, okay, but this does have a lot of values, and there are a lot of values here further away. There's a lot of value. There are a lot of perfect scores here. Like if we're assuming that we're doing a right hand evaluation of this thing, there's a lot more here than here. Okay, further away. Okay, there's still a small amount to the right, but we have that on the other one as well. So if we get a lot of data that's further away from the mean, then it's a bigger standard deviation. Okay, but that one's kind of tricky. So it just means that this last column has a lot more weight, okay, to the standard deviation. It's more spread out. The data. Think of like the balancing point on this, right? Maybe that's a better way to think about this. Is if you were to balance all this on a lever, Okay. Here's my balance. Here's your fulcrum, right? And if we started stacking weights like this, right, it would be fairly balanced. But if we started stacking weights like this, okay, what would happen? Which way would it fall? It would fall this way. Okay, this would be balanced. This one would fall away. Why? Because we have a lot of weight further away from the middle. Because we have more weight further away from the middle, it's going to fall. It's going to lean further to the right. And since this leaning, think of this as you know, the weight of your data is going to lean further to the right, it's going to make it unbalanced, and your standard deviation is going to be bigger, okay? Because we got all this weight further away from the fulcrum. Okay? If this weight was over here, okay, then it would be more balanced. Okay, but since we've got all that weight to the edge, it's less balanced. Okay. Okay. There was number 46 and 23, I think. I don't know if we went over 23 or not already. Okay, we'll do that. Went through that one. Okay, 46. Okay, students measure circuit boards produced by 4 machines using different methods for production. Without doing the calculations, which machine's measurements have the smallest standard deviation? Which machines, without doing any measurements. Okay, that's fine.
What question is this? Sorry.
What question is this? 46.
Thank you.
So which machine is going to have the most data that's spread out, and which one's going to have the least spread out data? Well, this data here in machine A is really bunched close together. B is pretty spread out. C is still really spread out, but not as much as B. And D is bunched together, but it's not as bunched together as A. So if it's saying without doing calculations, what's at the smallest standard deviation? The one that's grouped closest together, I'm going to go with A on this one. Okay, and I was right. Okay, so those ones, yeah, those are kind of hard. Did I turn? Getting some echo. Maybe that's from that. Okay, and then number 14, I think. Laney wanted 14. Okay. Let's do 14 here. 14. If you have your mic on. 14. Okay. In a large city school system with 20 elementary schools, a school board is considering the adoption of a new policy that would require elementary students to pass a test in order to be promoted to the next grade. The PTA wants to find out whether parents agree with this plan. The following idea for gathering data is proposed. Put an ad in the newspaper asking people to log their opinions on the PTA website. What kind of sampling strategy is involved here? What, if any, sources of potential bias do you see? Okay, so let's go back to our sampling. I think this is like a voluntary sampling, right? Isn't it? Wouldn't it be voluntary? Okay, and then you would get like voluntary bias because the only people who you're not requiring people to do this, right? So the PTA wants to find out whether the following ideas together data is really put an ad in the newspaper asking people to log their opinions on the PTA website. Yeah, you're just asking people to do this. You're not forcing them to do this, and the people who really want this new policy might be more inclined to go on. You know, people who want yes on 22 here, or whatever it is. Whatever the thing. Can you guys believe it? Like the election is a week away. That's crazy. Just craziness. Can't believe it. Is anybody able to vote in here? Is anybody actually able to vote this year? Not yet. Yeah. My son's in the same. My son's in the same boat. His birthday's in February, so he's like, "Yep, missed this one by 3 months." You know what I did? I just gave him my vote. I told him, I said, "You tell me who you want me to vote for, and I will vote. I'll gift you my vote this year." And so it was really cool. We sat down at the kitchen table, we went over all the propositions, and he told me exactly what he thought, and I told him exactly what I thought. And then I just said, okay, you know, I'll give you my vote. So we didn't really agree on a lot of them. It was kind of interesting to, yeah, I already mailed in my vote already. So it's already mailed. I did it like 3 weeks ago. So yeah. So because like with the whole presidency thing, like I didn't even care about the presidential vote. Like in California, it really doesn't care. Like we're the bluest of blues, right? So so there's 4 states you want to watch on election night, okay? 4 of them, only 4. You want to watch Pennsylvania, you want to watch Florida, you want to watch Texas, and you want to watch Wisconsin. Okay, those are the 4 states that are going to decide the election. So California, New York, those are already in the bag for the Democrats, right? They're already good. But those 4, election night. So if they say, oh, we project, you know, somebody will win for Florida, you're like, dang. Then we pretty much know who's gonna win the election. And then they're like, oh, we know who won for Pennsylvania. And then you're like, dang, now we really know who won the election. So it's just the way the Electoral College works. So just a little heads up, you know, maybe your parents didn't know that trivia. Like, oh, gotta watch those 4 states. Those are the 4 that are going to decide the election this year. So, and Texas, if Biden takes Texas, it's all over. I'm just going to tell you that right now, all over. If he takes Texas, there's no way. There's no way. So. Okay. Anyway. Okay, so what kind of sampling strategy is involved here? Again, I think this is voluntary, but let me look at my notes. Let me look at my notes. Okay. Yeah, I'll do that. Okay. Yeah, it's voluntary response is the bias, and what is the sampling? The sampling is voluntary response sampling. So I think it's both voluntary response. So voluntary response. Maybe it's called something else. I don't know. Maybe that's why people are getting this one wrong. Oh, that's not the bias. It's just voluntary response, and then voluntary response bias. Submit the question. It didn't like what I typed in there. Okay. Okay, let me log in differently here. Done. I'm just gonna hit done. Okay, so number is this 14? Details. Okay. Okay. Yeah, the fill-ins are really hard because you're like, if you type something that the computer doesn't like, then it's just not going to like it. It's not going to take it. Okay, so let me go to assignments. It's very finicky. That's exam 3. Yeah, there we go. Exam 3 review. Okay, teacher preview. Let's do the teacher preview. Okay, so number 14 this was. Okay. What the frick? Get similar question. Okay. So submit question. Does it tell me the answer? It doesn't even tell me the answer. It's so not right. Okay, I'm gonna get rid of this one too. I'm gonna get rid of question 14. 14 is gone because that's the right answer, but I don't know why it's not accepting it. Maybe I didn't type it in right, or the question 14 is gone as well. What is the answer to this? Let me go in here and see. Let me see what the answer is. Will it even tell me what the answer is? What did the computer want? Question 14. Find out. This is Jennifer's question. Jennifer, you made a pretty interesting question there. Actually. Let me preview your question. Nope, that's not it. That's not question 14. Am I on the right one? Oh, this is, oops. I'm not on the right one. Okay, so let's go to questions. Stop. Question 14 here. Nope. I want questions. Here we go. This is more like it. Question 14. Identify sampling bias preview. Boom. Okay. It says, okay, author, question these libraries, sampling, blah, 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 blah. Okay. So then what's the action here? The action is just going to be to withdraw the question. Withdraw question. Boom. There we go. I didn't like that one. And what was another one I didn't like? I think it was 45 I didn't like either. Preview that one. Yeah, it was this one. I didn't like that one either. Actions. Let's withdraw that one too. Yep. Is there any other? No, that's good. 40 is a great one. Okay. I'll withdraw those from the review. Make sure that they don't show up in the exam either. Okay, cool. Okay, how are we doing in the chat here? Doing good. Question 17 and 35 have the same problem as 14. Ooh, okay, let's see. And 23, okay, so what's 23 here? Read value from histogram. So let's preview that one. Based on the histogram above, what is the frequency of the class containing the value 14? Okay, well, the class containing 14 is between 13 and 17, and that's 7. So I'm going to try 7 here. 7, submit. Yep, that's it. Okay, so that was that. Between 13 and 17 is 14. So that one was good. Okay, and then Caitlin says, 17. Let's go to question 17 here. Okay. Identify sampling and sampling strategy and bias. Yeah, but Richards are usually good. So 2 charts, but the difference seems larger for the graph on the left. Why? Oh, this is just submitting. Oh, yeah, this is kind of like a free response one. Yeah, I'll get rid of the free response one too. Okay, withdraw that one. Withdraw the question. Okay. Let's see what else we got. You said 39 was problematic. Okay. Interpret standard deviation, essay context investments. Oh, it's an essay question. Yeah, let's get rid of that one too. I don't like the essay questions. Withdraw. There we go. Okay, perfect. Okay, good. Okay. Thank you, Caitlin. Okay, any other issues? Okay. Oops. Let's go back to Kim's. Okay, well, if there's no more questions, then I'll just let you guys go and study. I will have what, today's Wednesday. Would it be, I think it would be helpful, would anybody be able to come to an office hour or a cram session between 1 and 2 on Wednesday? Would that be helpful to hold a last minute question session from 1 to 2? Would anybody be available for that? I mean, you're in other classes, 1 to 2. Okay, so if you have last minute questions, okay, we will not have an office hour tonight. We will go back to our regular scheduled office hour of 1 to 2 on Wednesday. Okay. Okay, sounds good. Okay, perfect. I will see you then. Okay. Happy studying.